On behalf of the University of Illinois system, I thank all of you for your participation in the 12th International Symposia organized by the University of Illinois system, Illinois Mexican and Mexican American Student Initiative, I-MMAS. I'm Elvira de Mejia, a professor and the executive director of I-MMAS at the University of Illinois system. I-MMAS organized this symposium on artificial intelligence, opportunities, challenges, and multidisciplinary collaboration in partnership with 5 institutions of excellence in Mexico: the Center for Research and Advanced Studies of the National Polytechnic Institute, CINVESTAB, the National Autonomous University of Mexico, UNAM, the University of Guadalajara, the Autonomous University of Querétaro, and the Metropolitan Autonomous University. And of course, the University of Illinois Chicago, the University of Illinois Urbana-Champaign, and the University of Illinois Springfield. Thank you, thank you, thank you for your generous collaboration. This symposium aims to promote the exchange of knowledge and experiences on the highly relevant topic of artificial intelligence, focusing on addressing its multidisciplinary dimensions and real-world applications. On behalf of I-MMAS, I thank all the 12 speakers for their meaningful and engaging presentations. This symposium will spark new collaborations, discoveries, and solve many problems. We have nearly 1,000 people registered, 970, I believe, from Illinois, from many institutions in Mexico, and colleagues from Peru, Colombia, Costa Rica, Argentina, Bolivia, Ecuador, Spain, the Netherlands, Portugal. Impossible to mention all of them. Welcome, all of you. I thank the moderators who will keep us on track and coordinate questions and answers. It's a pleasure to have here Doctora Teresa García Gasca, Universidad Autónoma de Querétaro, and Dr. José Andino, University of Illinois Urbana-Champaign. I thank the people facilitating this symposium behind the scenes: Nancy Salinas, Eric Olson from Educational Application Support Specialist at the University of Illinois system, and Mr. Aldo Mora from UNAM Chicago. I thank all authorities and representatives of different institutions for their presence and support, especially Dr. Timothy L. Kalin, President of the University of Illinois system. I'm pleased to introduce now Dr. Timothy Kalin, the 20th President of the University of Illinois system, which includes universities in Urbana-Champaign, Chicago, and Springfield. Since taking office, President Kalin has led a surge of growth across the state flagship university system. Enrollment is at record highs, including increases among in-state and underrepresented students. President Kalin, a leading scientist and researcher in geophysics and space sciences, champions efforts to expand research discovery that drives progress and job creation. That includes helping lead the creation of the Discovery Partners Institute, a world-class research, technology, talent development, and business building center in downtown Chicago, and the Illinois Innovation Network, a system of satellite hubs that combine research, public-private partnerships, entrepreneurship, and workforce training to spur inclusive economic development across the state. President Kalin was elected to the National Academy of Engineering in 2007 and is a member and past president of the American Geophysical Union. A native of Wales and US citizen, President Kalin received his bachelor degree in physics and astronomy at University College London, where he also earned his doctoral degree in atomic and molecular physics. It's my honor to have President Timothy Kalin deliver the welcome remarks, and I'm delighted to pass the virtual microphone to him. Thank you.
Greetings and welcome to this important symposium, Artificial Intelligence, Opportunities, Challenges, and Multidisciplinary Collaboration. I am Tim Kalin, President of the University of Illinois System. Today, you will all have the opportunity to engage with so many practical applications of AI, a powerful and, of course, still developing tool. I want to thank I-MMAS and its founder, Professor de Mejia, for bringing all of you together for this important event. I-MMAS was built to bring us together across the border between our two countries, to work towards solutions to challenges we share and create opportunities for people in both of our countries. This event is a perfect example of I-MMAS at work. I am also deeply grateful to our partners in Mexico who are with us today for helping make this possible. CINVESTAF, the National Autonomous University of Mexico, the University of Guadalajara, and the Autonomous University of Querétaro. I am delighted that the sessions today also include outstanding faculty from all three U of I system universities in Urbana-Champaign, Chicago, and Springfield. Me da mucho gusto dar la bienvenida a algunos de nuestros colaboradores en México, como UNAM, IPN, CINVESTAF, UA, Guadalajara, para platicar con nuestros investigadores en Chicago, Springfield y Urbana, en un tema de actualidad como es la inteligencia artificial. Estoy muy feliz de dar la bienvenida. The agenda for today will give you the opportunity to consider, among other subjects, how AI can be used to assess the safety of traveling by bicycle in Chicago, the role of language engineering in social media, using AI to help diagnose oral cancers, how deep learning can enhance smart agriculture, and importantly, considerations about the responsible and ethical use of AI. I want to thank all of our panelists today, but in particular our keynote speakers, Professor Neetu Singh from the University of Illinois Springfield and Carlos A. Coelho, a research professor from the National Polytechnic Institute in Mexico. I'm also delighted to welcome and thank our closing speaker, Professor Marco Vinicio Ferrusca Navarro of the Metropolitan Autonomous University in Mexico. Today's event will provide a tremendous opportunity to explore just a few of the exciting multidisciplinary possibilities of AI. I hope it will also be the spark for future collaborations in this dynamic and revolutionary space. Thank you all for being a part of these important discussions.
Thank you very much, President Kalin, for your kind words and continued support of I-MMAS. It is my honor to introduce the first keynote speaker, Dr. Carlos Coelho, a distinguished professor of computer science at CINVESTAF National Polytechnic Institute in Mexico. He has received several awards, including the National Research Award from the Mexican Academy of Sciences, the National Medal of Science in Physics, Mathematics, Natural Sciences from Mexico's presidency, the World Academy of Sciences in Engineering Sciences, and the IEEE Computational Intelligence Society Evolutionary Computation Pioneer Award. He is an IEEE Fellow. The topic towards evolutionary multi-objective machine learning challenges and promises. It's an honor to have him with us today, and I'm delighted to pass the microphone to Dr. Coelho.
Thank you. Good morning. Thanks for the invitation. So my talk is about a topic which is very popular right now in my area, which is evolutionary computation. And of course, I won't have enough time to do a long introduction of the topic, so I will be very brief in showing the generalities of this topic. First, before talking about evolutionary algorithms, I would like to talk very quickly about multi-objective optimization. Multi-objective optimization is an area that arises in most disciplines, particularly in engineering, in applied sciences, and it refers to solving optimization problems in which we have two or more objectives that we want to optimize at the same time. But the main difference here is that at least some of these objectives are conflicting with each other. This means that improving one objective may deteriorate another one. This is an example. I want to optimize a bridge, and perhaps the two objectives that come to mind are cost and safety. But these are conflicting objectives, because if I want to increase safety, normally I have to add more material to the bridge, which increases cost. So these are the problems we are interested in multi-objective optimization. The first issue in multi-objective optimization is the notion of optimality. Unlike global optimization, in which the notion is very intuitive, we try to find the best solution in all the search space. In here, we are really aiming for trade-offs. This notion was originally introduced by the economist Francis Isidro Edgeworth in a book he published in 1881 called Mathematical Psychics, but it was the Italian economist Vilfredo Pareto who generalized this notion that he called ophelimity, and it refers to finding the best possible compromise solutions among all the conflicting objectives. In other words, what we call Pareto optimal solutions or Edgeworth Pareto optimal solutions are those in which it's not possible to improve one objective without worsening at least another one. And because of the conflicting nature of the objectives, this definition will generate a set of solutions rather than a single solution. So mathematically speaking, this is an ill-defined optimization problem because we don't find a single solution. Now, evolutionary algorithms, and I could say population-based meta-heuristics in general, are particularly suitable for solving multi-objective optimization problems because they offer two important advantages. The first is evolutionary algorithms, as well as several other population-based meta-heuristics, are stochastic in nature. With evolutionary algorithms, we try to simulate natural evolution in a computer, and we base the simulation on the use of random numbers. So this stochastic component is important because these approaches are more robust to noise, to lack of information, and also to high nonlinearities in the objectives that we are trying to optimize. So this is an important advantage. Because most mathematical programming techniques that are used for multi-objective optimization are gradient-based, which means we need to have the gradient available or we should be able to estimate it. The other advantage is that because they manipulate or operate on a set of solutions, which is what we call population, it should be possible to generate several different elements of the Pareto optimal set in a single execution of the algorithm. This is normally not the case with mathematical programming techniques because in those algorithms, we generate a single solution each time that we run the algorithm. So these are two important advantages, and that's one of the reasons why evolutionary algorithms have become so popular for solving multi-objective optimization problems, particularly in the last 20, 25 years. So in recent years, of course, machine learning has become a very hot research topic, particularly with the sort of popularity of deep learning. But what about evolutionary machine learning? Evolutionary machine learning is not a new area, has been around for a long time, but the focus of research in this area has changed, I will say, a lot in the last 10 years or so. In the old days, since the second half of the 80s, evolution machine learning focused a lot on evolving neural network architectures. And that was pretty much the only application of evolutionary algorithms in machine learning. But today, this has changed. There are many other applications, and also people are looking at the other direction to use machine learning techniques to improve the performance of multi-objective optimizers based on evolutionary algorithms. Zhao Shujin, who was first in Germany, then UK, now he's back to China, he pioneered the use of multi-objective optimization techniques in machine learning. He published a book in 2006 in which he already covered topics that will become very popular in the years to follow, like multi-objective clustering, feature extraction, feature selection, multi-objective learning, accuracy improvement, multi-objective learning for interpretability, improvement, and multi-objective ensemble generation. All these topics are covered. This is an edited book. He has chapters on these different topics, and he opened the door to get people with some background in machine learning to get interested in multi-objective optimization. In 2008, he published a paper in which he indicated that machine learning is inherently a multi-objective task because we normally have two or more objectives that we are trying to optimize, for example, when designing a particular topology for a neural network. And we normally have two or more objectives which tend to be conflicting with each other. For example, we want to reduce the complexity of the network or the size, but at the same time, we try to improve its accuracy, to maximize its accuracy. He also showed that the first attempts to incorporate multi-objective optimization into supervised learning date back to the mid-1990s. So in other words, this topic had been around already for several years, even in 2008. Other topics such as multi-objective clustering, multi-objective feature selection, and multi-objective ensemble generation have remained relatively popular over the years. I will say particularly multi-objective clustering and multi-objective feature selection. There are several research groups around the world. There is an important one in New Zealand that has done a lot of work on multi-objective feature selection, which was not that popular about 15 years ago. There were few people working on that, and now I believe it's very, very popular. In recent years, other topics such as multi-objective hyperparameter optimization have been explored. There is this paper from 2023 in which the authors indicate that in several specific multi-objective hyperparameter optimization applications, there are several objectives that could be considered, several of which are conflicting. For example, operating conditions, prediction time, sparseness, fairness, interpretability, and robustness. And in another survey, also from the same year, they mention other objectives on top of the ones mentioned before, like error-based performance of the target machine learning algorithm, inference time, model size, and energy consumption, which is now a big concern considering the computational resources that are required, for example, for generative AI. Something interesting is that the machine learning community at large seems to have great interest in multi-objective optimization. I have talked to several people, for example, 2 years ago in the Netherlands, several machine learning people. And you can find some papers like this one from NeurIPS in which the authors use a multi-objective approach, but this is not a meta-heuristic. They use a gradient-based multi-objective optimization approach with something called adaptive reference vectors, something that we also use in evolutionary computation for deep learning. But although in the paper they mention multi-objective evolutionary algorithms, what they indicate is that they are not really suitable for these applications because they only operate in a small scale problems, which to a certain extent is true. Also recently, there is this interesting paper trying to provide a theoretical framework to justify the use of multi-objective optimization in machine learning tasks. I won't get into the details, but basically what they conclude is that there are some advantages that could be mathematically proved when incorporating multi-objective approaches instead of single objective approaches into some machine learning problems. Also, there have been attempts to accelerate the training of deep neural networks using high-performance computing resources, posing the problem as a multi-objective optimization problem. This is an example, this PhD thesis from 2021 from the University of Oregon. And there is also some work in which they use multi-objective evolutionary algorithm, this paper from Loney in 2020, in which they propose a framework called DeepMaker that uses a multi-objective evolutionary approach that exploits a prune design space inspired by a dense architecture. And they consider the two objectives that make more sense, accuracy and the network size factor. Another topic that has been relatively popular in I will say last 15 years or so, in which even some people in Mexico have done some work, is multi-objective reinforcement learning. This is a very interesting idea of how to extend the traditional reinforcement learning algorithm to consider more than one objective. In this case, for example, they use a temporal difference learning algorithm that they call Pareto Q learning, because Pareto optimality is the concept we use as we saw before. And with this, they integrate this notion of Pareto optimality into reinforcement learning. But there has been more work in the same or a similar direction, trying to deal with either linear or non-linear approaches or both with reinforcement learning. So clearly, machine learning can also be useful to solve multi-objective optimization problems using an evolutionary algorithm, but introducing something that makes the approach more efficient and perhaps more general in a sense. There is a survey published in 2021 where they mention lots of references, about 400 papers dealing with this topic. Now, to summarize, it should be clear that it is possible to find intersections between machine learning and multi-objective optimization in both directions. We can either use multi-objective concepts to produce new machine learning models, or we can use machine learning techniques that can improve the performance of multi-objective evolutionary algorithms. However, in both cases, there are several issues we have to deal with. So in the first case, multi-objective optimization has already shown to produce benefits to machine learning techniques. Unfortunately, as I said, this has been done with mathematical programming techniques and not with meta-heuristics, which could offer some advantages. So one example is generating solutions or hyperparameters that produce more balanced classifiers in terms of accuracy and computational cost, and also improving some features of a particular neural network design. In the second case, there are already practical applications of the use of machine learning techniques to aid multi-objective optimizers. I give a couple of examples here. But let me go very quickly just to conclude with some of the challenges in the two directions. And first, when using multi-objective evolutionary algorithms in machine learning, of course, the main issues are at least these four: scalability, because multi-objective evolutionary algorithms normally operate in the domain of thousands of decision variables and not millions or billions. And it's not that they cannot solve problems of that scale, but they take too long to do it. So we need to improve our parallelization techniques, for example, to get to this domain. Hybrids, of course, there is a high potential, I believe, perhaps the highest in terms of combining gradient-based techniques with multi-objective meta-heuristics. Efficiency, we need more efficient applications and implementations. And also, we need to do more work on the theoretical foundations that justify the use of multi-objective optimization in machine learning. In the other direction, if we want to use machine learning techniques in multi-objective evolutionary algorithms, I can identify at least three issues. First is efficiency, because we cannot use a machine learning technique that requires too many computational resources, that takes too much time, because then the machine learning algorithm will consume more time than the optimizer itself, right? So we want to balance this. And this will require also efficient parallel implementations. Something I call domain identification. So clearly, we cannot always justify to use machine learning in multi-objective evolutionary algorithms. So it's necessary to characterize what sort of machine learning techniques will be more appropriate for what particular cases. For example, very large scale multi-objective optimization, noisy objective functions, or computationally expensive objective functions, in which we already use machine learning, but these models are very primitive. Normally, we use polynomial approximations of highly nonlinear objective functions. And also multi-objective reinforcement learning, I believe, has a lot to offer in the next few years, and we will see a lot more, perhaps not only on the incorporation of multi-objective optimization, but also in terms of developing hybrids with meta-heuristics. And that's all from my side. I think I finished on time, so we have some minutes for questions.
And now it's my great honor to introduce our next keynote speaker, Dr. Neetu Singh, Associate Professor of Management Information System, College of Business and Management, University of Illinois, Springfield. Dr. Singh is the co-founder at the University of Illinois, Springfield of the AI Campus Learning Community, which promotes artificial intelligence literacy on campus and beyond. Her research interest is in tactic decisions using actionable intelligence and advanced analytics. She performs integrative studies in healthcare informatics, information system, and business analytics. She received 3 Best Paper Awards for her research on decision making. She received the College of Business and Management School of the Year Award in 22 and the Service Award in 24. The topic is responsible and ethic use of AI. It's my honor to have Dr. Singh with us today, and I'm delighted to pass the virtual microphone to her. Dr. Singh.
Thank you, Professor Meghia, and greetings, everyone. It's an honor to be one of the speakers at the University of Illinois Systems Conference, sponsored by Illinois Mexican and Mexican American Students Initiative to discuss the artificial intelligence opportunities, challenges, and multidisciplinary collaborations. Today, I will be discussing the responsible and ethical use of AI and explore the kind of world we are building with AI and its use. We have observed that in a short duration, AI evolved exponentially, and AI is not limited to computing alone. It has become pervasive enough to reflect our values, our biases, and our aspirations. Whether it is technology, policymaking, art, teaching, or learning, the use of AI is reshaping how technology teaches day-to-day activities. AI isn't just about the capabilities it brings, it's about how we choose to use this capability to benefit the mission and goals responsibly and ethically. With our diverse experiences and perspectives, we have the opportunity to shape the broadening use of AI as it evolves. Before diving into the responsible and ethical use, let's explore that why AI matters. We have seen that currently every organization, every domain, every individual is almost using AI. But how AI enhances the efficiency and user experience is very important. We need to emphasize on that aspect. AI increases the productivity, it drives the innovation, and it improves the decision making with the informed data decision making. In a recent study by McKinsey, 92% of the companies plan to increase their AI investments over the next 3 years. Forbes mentioned that the AI market size is projected to reach about $1,339 billion by the year 2030, which is up from $214 billion in 2024. And Forbes further emphasized on that 64% of the businesses believe AI will increase their overall productivity. If we look into what are the different applications of AI, AI has been used in and is being evolving, and it's being used in so many different domains, starting from agriculture, cybersecurity, education, environmental management, finance, healthcare, logistics, transportation, and public services, and it's exponentially evolving over time. And there are many industries, there are many organizations and individuals who are using AI for the improved decision making. Now, with every advantage or every advancement in technology, there are the challenges and risks associated. And similarly, artificial intelligence integrates diverse sectors at a rapid pace, but these systems bring different challenges and risks that previously were not exposed. So when we deploy artificial intelligence, there are potential challenges of using artificial intelligence, which includes ensuring compliance with evolving regulations, to integrate new technologies with existing systems, and successfully navigating these issues requires addressing technical, cultural, and ethical concerns. If we look into the potential issues, it's important to ensure that data security and compliance regulations are followed in the specific geographical region, in the specific organization, and by the individual to maintain the data privacy concerns. It's important to address biases in the AI algorithms and the way we are using to understand the ethical considerations or implications of using AI. There is a high initial investment and ongoing maintenance costs, which are associated with the implementation of AI, and that is one of the challenges that need to be addressed while using AI. There is a skill gap as the AI technology is evolving in a very fast pace. So there are expertise which are needed to use those AI tools and technologies. So there is a challenge to fill that skills gap. There is a challenge with the adoption because there are the fear that a job displacement can happen and there is a resistance to change. So how the AI can be adopted ethically and responsibly, that challenge need to be addressed. Last but not the least, there is AI will be integrated with some of the existing systems, the legacy systems within the organization or an individual who is using AI, it might need to be integrated with some of the existing systems they are using. So it's important to address the challenge of interoperability, that is integrating AI with legacy systems and ensuring the interoperability. In addition to the challenges, there are various risks in using AI, including the potential bias, privacy breaches, and a lack of accountability. As AI systems become more autonomous and complex, these risks become more challenging to manage, making ethical governance and safeguards critical. We see that there are so many AI models, there are so many AI applications and tools which are available, and we have came across the biases, that is the systematic and unfair favoritism or prejudice within the AI systems, which can lead to discriminatory outcome. So it's important that the AI application is used ethically and equity is maintained when the models are being developed. And that can be achieved through the data usage. It's very important when an AI model is developed and when a user uses the AI system, the amount of data, the type of data or information that we enter into the system or the data that has been used by the AI system, that is a balanced data and that is informed data. So we have to be careful about what we are entering into the system and what we are getting out of it. Maintaining the confidentiality of the data. So we have to be careful how AI system is maintaining the confidentiality, and it aligns with the regulatory compliance as well. And AI algorithms need to be transparent and explainable, that how the information and the decision has been derived on. That is very important when we are using AI. And as a user, we need to be very careful that when we are using an AI system, we understand the transparency and accountability policies of the AI system. As a user, we are also accountable on using the information. So we have to ensure that we validate the information that is being generated by AI. And before using that information, we make sure it's also coming from a reliable source. So in simplified terminologies, consider ethics is the foundation and responsible use is the strategic implementation to achieve the outcomes from the use of AI. Now, before going into the responsible and ethical use of AI, it is important to understand that what does ethical AI mean and what is responsible AI mean. Sometimes ethical and responsible AI is used interchangeably, but there are key differences between the two. If we look here, ethical AI is a philosophical approach, and it focuses on the abstract principles like fairness and privacy, while also examining the broader societal implications of widespread AI usage. An example of ethical AI would be that if a researcher is investigating the AI's impact on the environment or its potential for workforce disruption, they are examining AI ethics. Responsible AI focuses on how AI is being used, and AI responsibility deals with the issues which are related to accountability, transparency, and regulatory compliance. An example of responsible AI is in a medical research setting, a responsible AI framework would ensure that there was sufficient transparency into the AI algorithm to understand and eliminate any biases that could arise from the use of the data. So if we see the appropriate data, the way the data is prepared, and if the data addresses the scope that we are trying to address is very important to eliminate those biases. So when it comes to AI, responsibility and ethics are interconnected concepts. Both investigate AI for potential ethical blind spots, while most business leaders will deal with responsible AI issues on a day-to-day basis, gaining an understanding of the broader ethical implications of AI use will support them in making informed decisions. Recently, an article in the Applied Artificial Intelligence Journal came up with an ethical AI framework where it's been discussed that there are three ethical dimensions of the AI use: transparency, fairness, and privacy. And these interconnected dimensions shows that how these aspects overlap and influence each other. And if we see here, when transparency is intersected with fairness, it leads to the accountability aspect or the accountability principle of the AI usage. When fairness and privacy intersects, it leads to the non-discriminatory data practices that need to be placed when we use AI or when an AI model is developed. The transparency and privacy ethical dimensions overlap, and they lead to the user trust, that how when we are using an AI system, a user trust plays a critical role. Transparency refers to the explainability and clarity of the AI model. Fairness refers to the equity and bias preventions, and privacy deals with the data protection and consent. And overall, the idea of responsible AI, which is presented here in the center of this Venn diagram, represents that this is where all three principles are balanced, leading to AI systems that are reliable, ethical, and trustworthy. And that is what we can visualize from this figure. So there are key principles that need to be followed when we look into the ethical use of AI. And if we look into, when we talk about the ethics, we have to understand the moral values that are associated with the use of AI. So fairness and non-discrimination, the AI systems should treat everyone equally, avoiding bias in their design and outcomes. So as a user, it's our responsibility that the information that we are entering into the AI system when we are using, we follow that principle as well. Transparency and explainability is another key principle for the ethical use of AI. And the way AI systems make decisions should be clear and understandable to the users, and it should allow the inspection and validation of the information or the decision that is being provided. Accountability and responsibility, it refers to the clear lines of responsibility for the actions and impacts of AI systems, and with the mechanisms for oversight and governance. So AI governance plays a critical role when we talk about the accountability and responsibility principle for the ethical use of AI. The privacy and data protection, there are AI systems, and these systems must protect personal data and uphold individual privacy rights throughout the entire life cycle of the AI system. So as a user, when we are using an AI application, we have to be understandable, and we have to understand that how this ethical principle plays a critical role. It's just like if we are using social media platform, We don't want to put anything in public which we don't want to share with everyone. It's the same concept that comes with the AI. Additionally, another principle is safety and robustness. These AI systems should be designed to be secure, reliable, and resilient against errors and malicious attacks. And this will minimize potential harm. So as a user, it's our responsibility that we understand the principle of using AI. Then AI is a computational model. It's a system that is giving us the insight. So human oversight plays an important role to ensure that the AI systems are augmenting and not replacing the human judgment. And humans should retain the control and the ability to intervene in decision-making process. Last but not the least, the societal and environmental well-being is one of the very important principles of ethical use of AI, because we saw that ethical AI is a philosophical approach of using AI. So the development as well as the deployment of AI should benefit society, promote sustainability, and consider broader impacts on human rights and the environment. So these are some of the key principles, and it's again evolving. As the AI is evolving exponentially, the principles will keep evolving, and we have to ensure that we understand those principles, those regulatory compliances of the geographical region that we are using, as well as the global recommendations for ethical use of AI, which are provided by different agencies across the globe. Now, for the responsible use of AI, it is important that as a user, when we are using AI, we are using it responsibly. So these are the three key principles for the responsible use of AI: privacy, confidentiality, and security. So the users of AI must follow the appropriate regulatory compliance to maintain the confidentiality of the data and information. Additionally, validating that the privacy and security guidelines are in place for the AI tool or technology that we are using is very critical. Auditing and accountability is another principle for the responsible use of AI, and users of AI must be accountable for implementing and enforcing the appropriate safeguards for the appropriate use and functioning of the applications that they are using to implement the decision making. The user should monitor, audit, and document compliance with the safeguards which are being aligned with their geographical location, with the domain that they are using the AI for, and with the global economic aspect that they are accountable for their actions. As we have seen earlier, that skills gap is filling up the skills gap is very important. So workforce empowerment is one of the another principles for the responsible use of AI, because individuals need to be empowered in their roles through training, guidance, collaborations, and opportunities, which will promote the innovation that aligns with individual or organizational goals when we are using the AI system. As we have seen through the literature and through the evolution of AI, that ethical and responsible use of AI is important, I thought to go and look and ask the AI tools to see what they think about the ethical and responsible use of AI. So I went to the Copilot and I just gave the prompt that, what do you think about the ethical and responsible use of generative AI tools? So if we see here, Copilot gave these three principles or some thoughts over their empowerment, trust, safety, and continuous improvement. But overall, it is saying it's crucial for ensuring that the use of AI, ethical use of AI, benefit the society while minimizing the potential risk. And it's also saying that it's about creating a positive impact while being mindful of the ethical implications. Now, if we see here, there are 4 thoughts that Copilot mentioned about the ethical and responsible use. I went to the chat GPT and I asked the same question. I gave the same prompt over here. What do you think about the ethical and responsible use of generative AI tools? So if we see here, the list looks longer as compared to the Copilot, but if we see, it's the categorization. So the categorization which is done, if we see trust was there in the Copilot, which is further breakdown into transparency and privacy, that how transparency need to be maintained, how the data need to be secured, how we have to ensure that we are not unethically using the data or information. So overall, again, ChatGPT also says that the ethical and responsible use is crucial, and it is we have to reinforce those ethical issues, and we have to ensure that biases are eliminated, it's fair use, and people are accountable when they are using it. And again, it says that it's important to balance the innovation with the ethical considerations, and it will be essential to ensure that generative AI tools are used responsibly. So if we see
Professor Singh, your time is up, so just plan to wrap up
Sure.
so that we can have a couple minutes for questions.
Sounds
Thank you.
good. Thank you. So to summarize, if we see how to ethically and responsibly use AI, understanding the AI ethical principles, that is the fairness and privacy guidelines and societal and environmental well-being is important. Ensuring that the AI responsible use policies are in place, more specifically to maintain the privacy, confidentiality, and security is important. Developing the knowledge for the data management, that is important, that how data is used appropriately. Human oversight is one of the most critical aspects. Mitigating the risk and biases that are associated with the use of AI and development of AI, those strategies need to be in place. One thing that I would like to align is, if you are planning to use AI for your domain, ensuring that you pilot the targeted AI use cases from that domain would be important to replicate it in the area. And last but not the least, the professional development is important. So responsible and ethical use of AI is a continuous journey of reflection, accountability, and collaboration. And as we get deeper into adopting AI, we need to maintain a focus on ensuring everyone benefits in an equitable and fair manner, respecting the moral values and serving the community. Thank you. And with this, I conclude my presentation. I appreciate your time and opportunity to present. Thank you.
Thank you very much for the introduction. And again, my name is Carla Tejada. I am a very new assistant professor in the Mechanical and Industrial Engineering Department at University of Illinois, Chicago. And I'm going to talk to you about some work that we have been doing that I just started at UIC, which is the use of AI tools to assess perceived biking safety in Chicago. So when we think about, when we think about safety, and I want to open these up for the public, and I know we have a lot of participants, but when we think about bike safety, what do you usually think about? And I'm going to give up around 30 seconds for you to put in the chat or in the Q&A the first thing that comes up to mind. And right, so I see a lot of things like broken elbows, helmets. There's no safe roads for bicycles, which I think it's true, and we're going to talk a little bit about this today. And pretty much what we hear a lot is that safety is the responsibility of the cyclist, right? So if we talk about helmet use, if we talk about reflective gear, about the cyclist has to be very attentive of the surrounding areas and so on. And usually this works, and the US has made a ton of advancements, but the US is still the leading rich country in vehicle-related deaths per 1 million of residents. So compared to other countries, we still have a long way to go. And what is interesting about this figure is that the second and third leading causes of these deaths related to vehicle accidents is related to pedestrians and to bicycles, right? So these are two of the categories that have to be more analyzed. And one interesting thing is that in Chicago, the latest safety report showed that although we did reduce a lot the number of accidents in the roads by including safety with cyclists and including a little bit more of bike lanes, actually the severity of the accidents increased by a lot. So before, if you could fall and, as somebody mentioned, a lot of scratched elbows, now the accident is going to lead to a more severe cost, right? So in another problem that we have when talking about bike safety is that most of the analysis done is using what we call crash data, which gathers all the all the accidents, vehicle accidents, bike accidents, and pedestrian accidents in some report, right? The problem with this crash data is that there has to be a police report filed in order for the accident to appear in the crash data. But when biking, or even when being a pedestrian, there are some type of accidents or some type of situations where we don't feel safe that are still not reported. So a lot of the research that comes from these from these crash data actually lacks a lot of information. So our first question was, are there any ways in which we can measure bike safety without actually relying on these crash data, right? And then we also talk about that there's a new discussion on bike safety based on the infrastructure of the city. Somebody mentioned there's not enough of bike lanes, right? There's not enough bike lanes. So a lot of cities are actually represented in the image on the right, where bicycles have to be sharing roads with other modes of transportation, including trucks, buses, and cars. But we want to move forward with the design of the infrastructure to more safe rides, right? And in Chicago, we've done, and actually, sorry, this is what we would love to see as bikers. And in Chicago, this happens only one day in the year. Actually, it's going to happen this weekend, and it's a right along the Lakeshore Drive, right? So they close Lakeshore Drive, and it's open only to people biking, walking, and it's very interesting and very nice if you get the chance to go. But we know that this actually cannot happen, and this is not sustainable in time because most of our cities are thought to moved by car, right? So in Chicago, there's a whole range of biking infrastructure, from higher stress roads to lower stress roads, having the Lakeshore Drive, the closer to the lake, as a lower stress off-street trail. But in most of the west side of the city, after that trail, we have higher stress bikeways with shared lane bike lanes and buffered bike lanes. So all right, so what we want to do with this project, and sort of the questions that we have and that we want to address with AI, is that we know that this project aims is to assess roads with high stress and identify instances where the vulnerability of cyclists increases. And then the questions that we have is, can we transition to safer roads, knowing what the biker feels? Can we transition into a more welcoming infrastructure? And also, what measures from the public planning point of view should be taken to accommodate bikes in irregular traffic? So for this, we want to analyze how do a biker feels. And to do that, we have a partner that has given us a biking data for a 1-year biking commuting data. Also, it's very important to note that it's very different when we bike for sports than when we bike for commuting, because for commuting, we actually have to go inside of the streets of the city, right? So I have 2 videos that I'm not going to play the audio, but we have 2 types of videos in here. So we have rear videos of these partners using the bike lanes or using the city infrastructure. And then we also have front videos, right, that look like this. And what we want to do by using AI and by using pre-trained models of AI is to recognize when a vehicle it's in close proximity to the bike, or when there are problems with the infrastructure that could be avoided or could be fixed, so as to make bike riding more safer, right? So this is sort of the models that we have that we trained, And this is the process that we use to run the models and identify proximity measures, right? So we started with the data collection, the partner giving us data, then the data pre-processing, data cleaning. These actually takes a long time, and we currently have more video information, but this data pre-processing takes a lot of time because we need data that uses the same segments pretty much. And also we need to clear out things, videos that are not clear. We need to clear out parts of the video where the same bike rider is conflicting with the camera, and so on, right? Then we use YOLO V8, which is an AI tool to recognize video modeling and image recognition. So as we can set up the model, this includes us telling the model what we want it to check, right? Then we run the YOLO V8. This takes a long time, and then we identify the proximity measures, right? Currently, we have a 74% of accuracy, and this increased a lot by the data pre-processing that we had, and that we're still working on. Again, this is a very new project, so this is initial results. And some of the results that we have for the proximity measures, we see that the partners that we have actually ride along very high stress data. And one of the things that we've seen is that during a 30 to 45-minute bike ride, a cyclist is close to passing cars around 30% of their trip. So if you imagine these, there is actually a lot of time that you pass by a car and this is not considering a parked cars, right? So this is only considering a road where there's no parking, just cars passing by. This means that there are a lot of opportunities that a car will be very, very close to you, right? As a biker. And then when we include parking on the sidewalk, this number actually ranges from 50 to 60% of these bike ride where the rider does not have accessibility to bike lanes and they are in very close proximity to other cars. There are very few routes where the cyclists are not close to vehicles, but this usually happens on lower street roads, say in trails or in protected bike lanes, right, roads. So this to be said that actually protected bike lanes do work more than just painting on the street, right? And then we also started the analysis of the infrastructure analysis and what do we need, right? And here we also use the biking infrastructure map generated by the Chicago DOT. And one of the interesting things in the map that you see in your left is that there's actually very few bike lanes that are on the lower stress side, right? We did not include the Lakeshore Drive because that is just not everybody has access to that, but the rest of the city is usually a high stress bikeway, right? So yeah, if you see in the map, there's a lot of red, orange, and yellow. And also we see a problem of disconnectivity in mainly the southwest and the south side of Chicago, right? The other thing we saw, because we have a 1 year long data, is that currently there are more bike lanes in the roads that we have analyzed, but in the times where it snows, most of the bike lanes do not receive service for a snow cleaning and so on. So these also increases the lack of safety in bike riding. And one of the interesting things that we found in this is that there are actually measures of safe biking infrastructure defined by the American Association of State Highway and Transportation Officials. And usually what they define is that a bike lane should have 5 feet in width, but in Chicago, many bike lanes do not meet this requirement. The newer ones do. But if we think that there are more type of bikes also being used in the system, these 5 feet is actually not enough. And then my specialty is working on urban freight, and say if we want to include cargo bikes in the system, this makes it very, very hard. And now we have seen a lot of personal cargo bike uses, and they usually don't even fit on the bike lanes that exist. So it's still an ongoing problem that we're trying to study and analyze. We welcome all the questions and also all the comments and recommendations that y'all can make. But some of the conclusions that we have is that bikes require space for safe infrastructure to reduce the number of bike accidents and the severity of incidents, right? And also in the infrastructure maintenance needs to be improved to ensure the safety of cyclists throughout the year, not only when we think people bike the most, but when people actually bike the most. These numbers also in the winter are corroborated by DV data. So yeah, that's the other conclusion that we have. And then the future work that we have, the four main topics that we're discussing right now is bike connectivity and equity. The southwest and south side of Chicago are the most disconnected, and we wonder why. There's also the design for bikes and other modes of transportation related to cycling. So I mentioned cargo bikes, for instance. We also want to create infrastructure hotspots of proximity. So are cars closer to bikes near a stop sign or near an intersection and so on. And also, how is the relationship between bike lanes and the proximity to like the bike lanes, lack of bike lanes, and then proximity to cars. And then what we would also like to make in the future is the design of cargo bike network to support companies and consumers, because there's a lot of opportunities while using bikes in Chicago. It's pretty flat. It's very convenient to ride bikes there. And also there's a huge amount of people that are interested in this. I want to acknowledge the work of my students, my PhD student, Utko. She is from the Mechanical and Industrial Engineering department. And then I also would like to thank my undergrad students who have been working on this for 1 year already. And we're working on a publication for these. Malik Hari, Dirash Erneni, and Dima Medvedkov. They are from the Mechanical and Industrial Engineering department and from the Computer Science department. I have found a great talent and quality in students at UIC, so I'm very, very happy to be mentoring these students. And with that, I would like to thank you. I think I'm right on time. So if I can answer any question, I'm happy to.
Hello, everybody. Please let me know. Can you hear me well?
Yes, you sound clear.
Yeah, sounds good. Okay, thank you very much for inviting me to present about the work from the Center for AI Innovation at the National Center for Supercomputing Applications. Just a few words about myself. I've been at the NCSA, at the National Center for Supercomputing Applications, for quite a while, since 1997. And most recently, I lead the Center for AI Innovation. This center was set up with sort of these four pillars in mind. First of all, we are interested in engaging with academic research, working with faculty and researchers on campus who develop AI technologies or who use these AI technologies for their applications. We provide opportunities for students to work on different projects in the center. You know, every semester we have anywhere between 20 to 30 students working in the center on different projects. We are also looking for opportunities with industry to collaborate with them on the development of technologies and application of AI-related technologies. And of course, we are interested in systems and tools for AI. Today, we'll talk about one specific project that is coming out of the Center for AI Innovation. This project is called Illinois Chat. Original name was UIUC.chat. And you know, I teach computer engineering courses, and typically I have 200 to 300 students in the course, and so students ask a lot of questions. And so at one point, the idea was maybe we can have an AI teaching assistant that can help to answer these questions. And so we started to build a tool like this, and this tool started actually. I've been using this tool since the fall of 2023. So already for a few semesters, and you know, this tool is now tool called Illinois Chat is now becoming available as a tool for the entire campus as a platform that University of Illinois provides to faculty to use for this and other applications. So I will briefly talk about what this tool is for, how it is built, and what this tool is good for. So basically, the tool is set up in such a way that an instructor can go and create a chatbot for a specific course, and can simply go and upload different types of materials into that. So I upload my syllabus, I upload lecture notes, the PDF files of lectures. I upload chunks of the textbook, some programming documentation that is needed for this course, and so on. But the tool can also scrape Canvas or can scrape a website, and it's very easy and very quick to set up a chatbot that is loaded with the course-specific materials. Once these materials are there, the students can ask questions, and their answers will be generated based on these materials. So it is as good as ChatGPT, except that it's better because it actually relies on the materials that the instructor provided, not the general knowledge of the ChatGPT. So instructor has a control who can have access to it. I typically make my chatbots to be open so that anybody who knows the URL can have access to, and I share that URL with my students. But it's also possible to restrict it to some set of email addresses, so only students in your class, for example, can have access to it. We also support a collection of large language models that can be connected to this tool. We originally started with just using GPT models, but later on we added support for other models. And more important, we actually also have a server where we run our own large language model, actually several of them. And it's possible to use our own large language model. And so your data never leaves the University of Illinois premise. It never goes to OpenAI or Google or any other places. And these models are open source models, are quite capable, and they are providing good responses. Instructor can also have ability to modify the prompt. So, and I've seen some instructors doing some very interesting work with prompts. They, for example, build prompts specific for a given lecture that, for example, for a given assignment of some sort that guides students through that assignment. So it's actually possible to do a lot with just prompting. We also have some different modes in which the chatbot can behave. Typically when you ask something from the chatbot, it gives you the straight answer. But if you don't want that, then there is this guided learning mode where it doesn't give a straight answer. Instead, it tells you how to get to the answer. And so this is very useful for if you are trying to teach students, if students are trying to use it actually to learn something rather than just to get the straight answer. We have the ability to see how this is used. I will show you another example of this, but there is this panel which tells, usage by day, usage by time of the day, usage by time of the day and the week, what type of models are used, how many conversations, and so on. So the instructor can see what's going on there, as well as to download the conversations and monitor them. We also have the ability to integrate to this tool. So, for example, if you have an application where you want to use the responses generated by the chatbot, we support an API integration and provide the code and keys how to integrate it. And we can also integrate third-party tools. So we use this platform called N8N, which enables us to connect to other external tools. And this could be databases, this could be web search, or this could be some references from other places. Why this is important? If you ask something like, what is the weather today? The chatbot is not going to tell you that because it does not know what today is and it does not know what the location is. However, if we connect the tool, and here's an example of using the tool called Wolfram Alpha, then we can ask questions like, in this case, what satellites are visible over this location at this time? The chatbot is going to call the tool, and we're going to get the response from this tool, and then we'll go with that to generate the responses. So it's possible to interface with the external world. And this has proven to be very important component for enabling sort of other users of this platform besides just the teaching. Yeah, so what are those uses? So originally this was invented as a classroom learning tool, as a teaching assistant, AI-based teaching assistant. But more recently, we've been also using it in all kinds of research-related projects, and we have some interesting examples where it works, as well as some projects which actually rely on the API capabilities. So in the classroom, the instructor has the ability to control what and when students can have access to. So, for example, it's possible to upload all of the lectures in the beginning of the semester, but then enable them section by section. It's possible to give labels to section to materials, and then enable them section by section as the course progresses. And the faculty generally have a lot of control over what and when and how is delivered by this platform. So here's an example of using this chatbot in ECE 408. There's stats for 3 semesters where it was used. So, for example, last semester, actually, yeah, this must be a typo. The last semester in the spring of 2024, there were 5,000 questions being asked and answered by the chatbot. Here's an example. One example, a student asks, what is this course all about? The chatbot goes and fetches all the documents and then it finds the syllabus, and based on the syllabus and gives a description of, yeah, this is what this course is all about. These are the things that will happen in the course. And for all of these statements, it actually makes a reference to the material that describes it in details. So students can click on any of these links and get the specific page of the PDF file that talks about this. So how students use this? They typically ask questions related to the concepts taught in the course. Sometimes they ask questions like describe how this function works. This is a programming class, so they ask how the different things work. They ask how to implement one or another primitive, things of this nature. But it's also possible to use in a very different way. So for example, here, a student can ask the following. I am preparing for the first exam. Please ask me questions about the first 3 lectures. Please check my answers and please tell me how good they are. And so the chatbot says, yeah, sure, here is the first question. What are the 3 main goals of this course? So the student types in, yeah, learn to program in CUDA. And the chatbot goes and says, yeah, this is one of them, but there are others, and gives the explanation and points to where exactly to read about this. And the chatbot is quite capable of generating this sort of conceptual questions and answers. So do they use it? Well, yeah, so this is statistics from the spring 2025 usage. Over 5,000 questions been asked and answered. Some statistics about the time or the day of the semester. We have a lot of questions being asked before the first midterm exam, and also some smaller number, but also a lot of questions before the second midterm exam. These are the type of models that students use. Here is an interesting view. This is conversations per day per hour. So there is a time of the day and there is a day of the week. And so we see this large number of questions being asked just before the deadline for our assignments. There are 2 deadlines actually there. There is one deadline on the Fridays, but then the final deadline is on Mondays, and students ask a lot of questions before the final deadline, and also as a function of time of the day. Okay, some other examples, sort of the research use. So we have this collaboration with AI Farms. This is an AI institute on campus. This AI Farms is build this tool where they scrape the documentation from Illinois extensions about agricultural production, and then now they have this tool where they can ask questions related to agricultural production. And we also have the ability to, for example, process images and detect something in these images and then give advice based on what we see there. Here is another example. We scraped the open access PubMed articles. And now we have a tool that one can ask questions against that knowledge base. And for example, the question, which genes are implicated in rare cancers? And this will go through the entire set of papers in PubMed and find those that have this covered in those papers, and we'll give you the explanation together with the links to the papers that have been used to generate this. You can ask more interesting, more involved questions that actually kind of do some synthesis. So for example, here the question is find the 20 gene mutations associated with a particular type of breast cancer, and then identify other type of cancers where they are implicated. And the tool is able to go and build this table of those genes, and then is able to go and find other references to them and build this table of what other cancers they are related to. So it's quite capable of, it's not really reasoning, but it's quite capable of synthesizing information from the given knowledge base. Another example is sort of a professional development or other projects, personal projects. Because we expose this API, we can actually can integrate this with other applications. And one such application that has been developed in my group is this visual nutrition mobile app. The idea is that you take a picture of something before you eat it. This gets converted through the AI tools into what exactly it is, and we can then connect it with a database to figure out what the nutritional components are, so we can show those. But more important, we can then ask questions about the food, and the chatbot will take into account what this food is, as well as the knowledge about nutrition and nutritional values for these foods and what's supposed to be good for you, and can generate a response telling, this is This is what how your food looks like. So we, as I mentioned, it's this tool been actively developed. We just this month we released it as a beta version for the campus users to use. And so there are a lot of other improvements on the roadmap for this tool. As a quick acknowledgement, there are a lot of the tool started, the implementation of this tool started in the Center for AI Innovation, but we have contributions from many others, in particular from Illinois Compute. In the most recent time, they are providing both hardware and staff to help to develop this to be a production tool. And the development of this tool started as a student project. And these are all the students who worked on this project over the past couple of years. We ended up hiring some of the students as research engineers. So Kasten and Rohan and Asmita and Rishka, all of this started as students and were eventually hired to be software engineers at NCSA to continue to work on this project. Okay, and I think I'm just on time.
It's a pleasure to be here, and I want to thank the organizers for bringing us together for this important conversation about artificial intelligence. Well, let me introduce myself. I am Gerardo Sierra, and for more than 25 years, I have led the language engineering group at UNAM, the National Autonomous University of Mexico. The title of my talk is Role of Language Engineering in Social Media. What I like to share with you today is not just research. It's about how technology, language, and human life come together. I hope that at the end of this talk, this will result in some kind of collaboration between our institutions. If you agree, as the challenges we face are global, so must be the solutions. To begin, let me tell you a bit about where the research comes from. UNAM is the largest university in Latin America, over 360,000 students, more than 40,000 faculty members. It is a UNESCO World Heritage Site and a place where culture, science, and innovation converge. On the screen, you can see some of our most well-known sites, the Central Library with murals by Juan O'Gorman, the Olympic Stadium of 1968, and the National Library of Mexico, where nowadays our group is currently based. At UNAM, I have tried that the language engineering group explores how artificial intelligence can make sense of human language, because at the end of the day, language is the most human thing we have. Let's talk about social media. Social media is not just a communication tool. It is really a mirror of our psychological and social state. Every post contains emotions, opinions, and needs. Platforms like Facebook, Twitter, nowadays X, and TikTok give us access to spontaneous real-time language. If we look closely, this digital trace reveals much more than individual thoughts. It shows us collective trends in mental health, political polarization, social concerns, and the spread of misinformation. In other words, social media is not just a network, it is the mirror of society. And this is where language engineering matters, because human language online is messy, fragmented, full of irony and talk and context. Our role is to turn that chaos into insight, to build tools that help us see patterns, emotions, risks, and opportunities. For this reason, we use NLP libraries like Spacey, NLTK, and Transformers, and we connect them with public APIs to build classifiers, perform topic modeling, or monitor sentiment in real time. So we can transform millions of voices into structured knowledge. And when we do that, We are not just analyzing texts, we are listening to society. Let me share 3 projects where we try to do exactly that. Apply these tools in real-world scenarios. As I have not enough time, just 15 minutes, I can only give you a brief overview, but if you scan the QR code, you'll find more information, including links to some of our publications. The 3 projects are detecting suicidal ideation on social media, understanding public sentiment during COVID-19, and mapping political polarization in Mexico. Each of these projects is a reminder that technology is not about machines, it is about people. In the first project, we analyzed Mexican Spanish social media posts with an extended dictionary designed to capture local ways of expressing pain. Using text processing and statistical modeling, we try to detect early signs of psychological distress. The goal was not surveillance, but prevention, saving lives by recognizing voices that remain silent in the outside world, but have a huge impact online. To do this, we compare text on depression and suicide with random posts and with validated phrases linked to known risk factors. The analysis relied on Luic, adapted with a Spanish lexicon enriched to include colloquial and digital expressions. This required developing specialized linguistic resources, building a processing pipeline to collect and normalize the data, and applying statistical models with bootstrap methods to identify significant difference between linguistic categories. The outcome goes beyond technical achievement. It demonstrates how language engineering is designed early warning tools that support mental health professional and create new possibilities for early intervention in online spaces. What we found is that suicidal-related posts consistently reveal linguistic markers. In fact, words linked to death, sadness, anger, and isolation. These patterns mirror validated psychological risk factors, showing that through language we can begin to hear the cry for help that might otherwise go unnoticed. In our study, suicide risk was detected in Mexican Spanish posts thanks to a customized Luic dictionary that included informal and net speak expressions. Text focus on depression and suicide aligned with validated phrases associated with hopelessness and self-harm. On the other side, the strongest signals appear in categories such as death, anger, sadness, and the frequent use of self-focused verbs. Together, these findings highlight how linguistic patterns can provide early, reliable cues of psychological vulnerability in online environments. This second project was born in the middle of the pandemic between 2020 and 2022, when fear and uncertainty shaped much of what we read online. We wanted to understand these emotions, so we built sentiment analysis models made for Mexican Spanish, because the usual tools just didn't capture the way we speak, especially in moments of crisis. To do this, we created the SendCovid corpus and the MyOpers platform. 1,000 of tweets were carefully labeled as positive, negative, or neutral, giving us a clear picture of how people were expressing themselves. And then came the challenge. Which models could be best read those emotions? As you can see in the chart, we compare traditional machine learning with the state-of-the-art transformer models like Beto and Roberta. The results show how much progress can be made when technology is adapted to the local language and context. The results were clear. Spanish-specific models outperformed generic tools. Beto case achieved over 73% accuracy, well above traditional methods like SVM or naive Bayes, and tools like TextBlob or Butter. These benefits were possible because the models were trained in Spanish and adapted to our context. All of this was integrated into the MyOpers platform at UNAM, which made it possible to us to track public sentiment during the lockdown, watching fear rise, anger spread, and hope emerge in real time. If you agree with me, for decision makers and health communicators, this kind of insight was not just useful, it was essential. Our third project is actually still ongoing, and it focuses on the Mexican elections of 2024. What we were looking at is how people talk about politics on Reddit, and how those conversations often turn into echo chambers. Basically, these are online spaces where you mostly hear what you already believe, and anything that challenges your views kind of disappears in the background. Now, this isn't just some online quirk. It can be dangerous because it splits society into separate realities where people live in parallel versions of the truth. Reddit is a fascinating case for this. On the surface, it looks like a bunch of independent communities, but when you dig deeper, political subreddits often end up reflecting the same power dynamics we see offline. So, what we are doing is mapping out the patterns of conversation and interaction to see how these online spaces shape political narratives during the presidential campaign, and how they make groups more cohesive inside these ideological echo chambers. So, even though this project is still in progress, we already expect to see some patterns that are very familiar. For example, people inside each group interact a lot with one another, which makes their community feel strong from the inside. We also see how conversations tend to align with the narratives that come out of the political campaigns. On top of that, things like karma and moderation play a big role. They help reinforce certain viewpoints while pushing others aside. And of course, algorithms and community filtering can amplify polarization, basically creating stronger divides between groups. What's really important here is what this means for us. By studying echo chambers, what can actually identify where bias and misinformation and taking root in the population. That gives us a powerful way to understand not only the dynamics of online communities, but also the risks they pose to democratic debate. Finally, I'd like to close by saying that language engineering is not just about algorithms. It is about listening, listening at the scale, listening to society, and listening to the voices that might otherwise go unheard. Our research group in language engineering reflects that spirit. Yes, we have students in computer science and linguistics, but also in psychology, law, medicine, political science, library science, and data science, and many, many others. The diversity of background gives us the perspectives we need to face some of today's most urgent challenges: detecting suicidal ideation, analyzing sentiment, and understanding echo chambers in social media. On the screen, you'll find two QR codes. The one on the left leads to more details about the project I just shared with you. The one on the right connects you to the social media of the language engineering group at UNAM. Thank you very much for your time and attention, and above all, for your commitment to thinking about the future of AI in society. I look forward to your questions and even more to the collaboration we can build together.
All right, so I would like to thank Dr. Demedja and the Illinois Mexican and Mexican American Students Initiative for organizing this meeting. I'm an associate professor at the College of Dentistry at University of Illinois, Chicago, and my expertise is in the study of RNA and DNA. And I'm going to talk today about the non-invasive study of RNA from the oral cavity. This is largely a study of gene expression, or the RNA that's made by cells or tissues that help make one cell different than another, but also unfortunately can lead to cancer. So the focus is on non-invasive collection of cells and analysis of gene expression, which allows you to detect oral cancer, but also allows you a window into understanding normal gene expression in human beings. Mostly this is limited to blood analysis. If you think about it, if you're going to do a study on how a vitamin or drug or nutrient affects the human body, it's hard to convince people to allow you to take a scalpel biopsy of some tissue. Instead, you just take blood. My focus here, though, is going to be on oral cancer. When a patient goes into the dentist's office to get their teeth looked at, there's also the soft tissue, which is not a focus of the dentist, but often patients have lesions. So these are both of the tongue, of course, different magnification, but the lesion on the left is an oral cancer, while the lesion on the right is benign inflammation. So the problem arises that a dentist is not equipped to biopsy this tissue. They're not trained to do that. It actually requires a lot of expertise to do it properly. So often what happens is the dentist says to the patient, how long have you had this lesion? Typically the patient doesn't know, and they say, if you still have it in 2 weeks, you need to make an appointment with an oral surgeon to have it biopsied, surgically biopsied, so it can be diagnosed. We set about doing this procedure, instead of using a surgical biopsy, to use a brush biopsy. And here's a picture of the brush that would be used to rub on the lesion for 10 to 20 seconds and obtain some cells. The standard method to do this is the scalpel biopsy, which takes tissue, and it's a mixture of tissue. So it's going to have the epithelium along with the underlying stroma, while the brush only takes the top epithelium. A side effect of this is that actually the brush actually gives you homogeneous cell type. So in some ways it's superior to using surgical biopsy. The second thing we learned about this over a few years of study is that this method works great only for a subfraction of RNA that your cells make, and that's microRNAs are consistently intact and easy to measure, while messenger RNA is not. So we focus thus on microRNA. One of the examples of how we started doing this procedure and verifying that it worked was he took a group of patients from the clinic. We had 10 tobacco users with oral squamous cell carcinoma, that's the standard oral cancer, and 10 patients that had never smoked that had oral cancer. And we also had brush biopsy of normal appearing mucosa of 10 never smokers without lesions. And the method we used to measure these panel of microRNAs, 370 in total, is RT polymerase chain reaction. It's an expensive, laborious method, but there are other methods that are faster, such as microRNA-seq or nanostring encounter, but those each have their own problems. One is not as sensitive, and the other one suffers from batch effects, in that if you do measure something one day and then the same sample a month later, you can get different results. This heat map demonstrates the kind of results we get. So each column here is a separate patient, and it's the RNA from that lesion. And each row is a different microRNA. And so the samples are grouped based on whether they came from normal oral epithelium, epithelium from a cancer lesion from a never smoker, or epithelium from a cancer lesion from an ever smoker, all obtained with the brush. And what we see is that these are genes that are, the red ones are genes that are more highly expressed. What we see is that expression is different in this group versus here, and the opposite effect is seen over here for these microRNAs. And so we are able to differentiate to some degree normal versus the cancer. But the other thing we observe is that there's a lot of you can't really tell the difference between the never smokers and the ever smokers. And this was one of the first indications that smoking, which actually is a major risk factor for oral cancer, these people that have oral cancer that never smoke, their cancers look very similar in regard to at least expression of microRNAs, and as people have shown later, messenger RNA. This is to reassure us that the microRNAs we see differentially expressed in normal versus in the cancer versus the normal tissue also are ones that have been reported when people do the same kind of study, except using surgical biopsy with microdissected tissue. This is a gigantic study done by the National Institutes of Health, National Cancer Institute, and we see some of the same microRNAs, 196A, 10B, 31, and also the same are over here. So this reassured us that the method was working, and the RNAs that were enriched were ones that you'd expect to see enriched. So now I'm going to focus on the AI part of my talk, and I'm more a molecular biologist than a computer scientist, but we have used artificial intelligence, classic machine learning tools for over 10 years to do the process called class prediction. And classical machine learning tools are best at doing best at doing a two-way classifier, separating groups, in this case, into cancers versus non-cancers. So for this experiment, we took RNA from brush biopsy of 27 oral cancer lesions, and from 27 patients. And then we compared these to brush biopsies from benign oral lichen planus, which is a disease of the oral cavity, which can look very similar to cancer, making it difficult to differentiate the two. Okay, so that was 21 patients. And this is just an example of, I'm going to skip over this actually. So here's what we see. This is a supervised classification. So we start out by telling the classifier which samples are which, and then it picks out the microRNAs which are differentially expressed and are useful for classification. Both of those criteria are both very important. So we see by this heat map that the things that are the microRNA, most of these microRNAs are poorly expressed in the lichen planus samples and are enriched in the cancer samples. Now, what's crucial here is for me to explain how this classification is done. And about 22 years ago, this was a very hot area in gene expression analysis and tumor diagnostics, and it still remains so. But this is one of the methods that was put forth, and it's known as random forest. And what is remarkable about it is it had several innovations that made it become so that it's still widely used today when doing simple two-way classifiers into two groups. And what made it special was that part of it is that instead of using making normal decision trees, what it does is it randomly selects several of your features, in this case, microRNAs, and will just use these randomly selected microRNAs to separate your samples. So it decides where it's going to cut off the two groups most homogeneously, and then it uses randomly a second feature or microRNA to decide again how to separate those. And many times it doesn't, on this individual level, it will not work. But if over a large group of this, random trees like this, it will come up with decisions on what's a sample you set aside, which one is what it is, whether it's a tumor or a non-tumor. And so what it does is majority voting to then make a final prediction, and methods that are accurate are set aside and labeled as accurate. So one of the innovations in this method is that there's bootstrapping of data so that you set aside not twice, you set aside data that you're not going to use for your prediction. And what that helps you do is avoid overfitting. In other words, you don't want to come up with a classifier that works fantastically, but it only works on your data. When you try it on someone else's, it doesn't work. So by using this methodology of setting aside data while you're training, and then when you're finally testing, validating and then testing, you come up with a classifier that will work when you have new samples. I should say there's other methods that have also withstood the test of time, such as support vector machines, here shown in this cluster analysis, where these are, say, tumor samples and these are non-tumor, and it's only shown for 2 axes. It can be as many as 10, 20, 30 axes. But based on these 2 microRNAs, if you can put a plane in between those 2 groups and separate the samples, that's what support vector machine does to come up with a classifier. Using this random forest methodology, we came up with 91 sensitivity for detecting oral cancer and 76% specificity, meaning we had 24% false positives when we use that level of sensitivity. Now, this is just the receiver operating characteristic curve, which gives you an idea of how accurate your methodology is. And this plots 2 things. One is true positives against false positives. So if you set your threshold very low for what you're saying is a cancer, you're going to be right 100% of the time. The problem, no, I should say that's right here. You're going to be right 100% of the time, but you're going to be wrong. You're also going to classify all the non-cancers as cancers.
Professor Adami, your time is up, so make sure to wrap soon.
Yes.
You.
So the three things, the important issues are why weren't we 100% correct? And there's several. One is we use different clinicians. This method, what is the question is sample heterogeneity. Are all the normal samples the same? And the solution is to actually use neural networks and deep learning to do this, which requires more samples. Okay, I'm done.
Well, I'm going to talk about discrete time fault-tolerant neurocontroller for nonlinear systems. Today, I'm professor of the Department of Information and Knowledge-Based Information, and actually I serve as Dean of Technologies for Cyber-Human Interaction. What is fault-tolerant and resilient neural control, and what is important? Well, it's well known that advances in science and technology implies always more complex and sophisticated applications, like chemical processes, robotics, aerospace industry, biomedical systems, and a lot of our most complex systems. We know that automatic system use allow us to improve productivity, to reduce time for responses, helping for adequate responses, rate precisions, and perform more complex tasks. Among efficient system performance are relieve human beings from repetitive and dangerous tasks. However, typically the flow that we follow to implement an application is, in the first place, select the system to be studied. Then the system usually is modeled. Traditionally, we always talk about mathematical models. However, in the current life, we can use mathematical models, computational models, conceptual models, mental models, among others. Then with this model, even this context of the model, we perform an analysis and then the design of a controller, a predictor, a simulator, an emulator, a classifier, or any other implementation. This design is applied in real time. The problem of this flow is that we don't always depend on the accuracy of the obtained model. Then one way to solve all the problems related to a real-time implementation is the use of artificial intelligence techniques. From my point of view, we can have three scenarios. The first one, we have an easy system whose model is known. However, even when the model is known, we can find parametric uncertainties, unmodeled dynamics, unknown disturbances, unreliable sensors, or inexistent sensors, noisy systems, which is always found with any kind of sensors, saturations in actuators, mainly due to energy constraints. We can find delays, we can find faults, zero attacks, false data imputation, and among a lot of other problems that are found in any real-time system. Besides, we can have a second scenario where the system has an unknown model beside all these problems. And in a third scenario, we can find a very complex system with all of these problems. Then we need to design resilient, adaptable, and general purpose intelligent systems. Although artificial intelligence systems are currently used only as a very powerful tool, there are many challenges that encourage current research in artificial intelligence. Most of them are considered by my previous partners in this symposium like explainability, traceability, reproducibility, reliability, implementation, computational power, bias, data availability, data labeling, education, ethics, legislation, and among other problems and challenges in artificial intelligence. Most of the people see artificial intelligence like a magic black box. Most of our students can see artificial intelligence like a union of blocks in any computational program. And I see artificial intelligence like a circuit or a system to be implemented, and it can be seen as a mathematical model that can be analyzed. In this way, one of the most challenges that I have is the implementation of real-time classification for fault-tolerant control. We know that all data classifiers can be used in health, finance, marketing, transportation, among other applications, and there are constrained due the data quality, interpretability, overfitting, fairness, data availability, and a lot of challenges and limitations. This mainly produced by real-time implementation. In this way, we propose the use of an approach based on intelligent control. Intelligent control wants to mimic that human operation for any kind of complex system, and they need to use concepts from different scenarios like control theory, neural network, fuzzy logic, learning theory, machine learning, reinforcement learning, among another kind of concepts. In the first place, we want to design a controller that is resilient. Why is important the resilience? Well, in a system in real time, we have a system which has an input control law computed. This is a theoretical control law. However, this control law needs actuators to be implemented. Then we have that applied control law is different to computed control law. This applied control law produces an effect in our system. This system can be under internal uncertainties as well as external disturbances. Even with these uncertainties and external disturbances, a state for the system is produced. However, this state produced is measured by a set of sensors. Then the signal that we can measure is not exactly the same that is produced. Then we need to consider error measurement as well as actuator error. For any accuracy mathematical model, it is important to consider these two errors. However, for data-based model systems, these errors are considered in C. Here we have the complete scheme for a fault-tolerant neural controller. In this scheme, we have the unknown system with internal uncertainties, with external disturbances, and we also include faults in actuators, faults in sensors, and we use a neural identifier to model all these blocks in red, which contain the system, uncertainties, disturbances, and faults for actuators for sensors. This neural identifier is trained online with an extended Kalman filter. Based on this neural identifier model, we can design a controller. In this case, a discrete time sliding mode controller. In a healthy situation, in an ideal situation, we don't have faults. However, in real-time situations, we have faults. Faults can be in actuators, faults can be in sensors, or faults can be in the system inside. Then we need to use a neural classifier to detect that fault. In a first attempt, we use the last value before the fault to freeze such value for an actuator or sensor fault. However, there are applications that are very sensitive to such values and doesn't work very good. Then we propose a neural estimation to approximate the signal in file. Then we have 3 neural networks in this scheme, one for an identifier, one for a classifier, and another one for an estimation. These 3 neural networks are working online. This is very important. And we can consider abrupt fault, incipient fault, or intermittent fault. In the first place, we apply this scheme to a 3-phase induction motor because it's a machine. There is no problem if fails, and it's very cheap. And we have first an experiment for test resilience. We put a very, very high external charge to stop the rotor of the machine. Immediately, the machine tried to follow the desired trajectory. Then we include faults in actuators and faults in sensors. Here we have fault in actuator 1, a second fault in an actuator, as well as in sensors. First for one current sensor, then another current sensor, and finally for position of rotor sensor. And we can observe that this neural network controller, besides the classification online, exhibits a memory effect. Each fault is produced a less hard transitive event. Here are the 3 faults for sensors, and we include load torque and aerosol resistance variation. Then, once this scheme works for a induction motor prototype, we proceed to apply this scheme for diabetes mellitus type 1 treatment. In this case, we cannot apply the same controller because for biomedical applications, we need to ensure that the control law is smooth. Then in this case, we apply an inverse optimal neurocontroller, and the neural network is a multi-layer perceptor. We obtain good results.
Dr. Alanis, can you conclude? You are in time.
Yes. We obtain a good controller. However, we include faults for a disconnection communication problem, and we have to include this approximator to eliminate this transitory event with very good results. This is with the estimation. And finally, we apply this classification in real time for different deep neural network models and machine learning models trained with data from a simulation, tested with data from a mathematical model, and finally validated with real-time patients. This is data from real patients. Well, thank you for your invitation.
I will start. We will talk about artificial intelligence in healthcare, but this is a very broad topic, and then I will focus on some projects more related to diagnostic, and then I will start my talk. Okay. Then I will start with an observation of some models of medicine. For example, sorry, I can lose my presentation. Okay. One moment, please. Okay. Yeah, then I will start about talking about medicine 1.0. It's a medicine based on tradition, more about observation, like the medicine about 1,000 years ago. And it is a medicine that it really works, but it's very limited. And then we have medicine 2.0, which is data-driven medicine. We understand the mechanics of the illnesses and the medicine, but unfortunately, it is more focused on treatment. And then we have medicine 2.0, which is the new approach. And now we are in medicine 2.0. And then in medicine 3.0, we are more proactive. It is personalized and it is preventive. It is difficult because it is personalized. It depends on each person to apply it. You can these models of medicine, you can see in this book that was written by Peter Appiah, which is a podcaster. In this approach, we have, for example, if we use medicine 1.0 or no intervention, the health span or health will decrease, like in this slide. And the problem is that as we age, we will have our health will be bad. And then if we use medicine 2.0, it's almost the same. Only in the last years of life, maybe we will live a bit longer, but with our health very decreased. And in this point, medicine 2.0, I think, is the best approach. And most of the life, or the lifespan, will be with a good health. And then at the end, it will decline. Okay, but why to use AI? The problem is that there is increasing specialized knowledge, and of course the number of illnesses or diseases that can be diagnosed, and also the availability of data and complex data. And also we need to increase efficiency in the medical sector. Here in Mexico, there are a lot of patients, and it is difficult to get good attention. Also, economic constraints, increasing population, and life expectancy. Okay, normally when we go to the doctor, they look at our history, they ask about symptoms, they check our medical history. Also, they ask a question about diet, exercise, smoking, etc. And then they do a physical examination, and if needed, they ask for some diagnostic tests like laboratory tests, imaging, functional. And then the doctor analyzes all this and gives some therapy. We can use a lot of data. I think it's important for artificial intelligence to have data. Now we have computing power. And then therefore we can use a lot. I think artificial intelligence can be used in many aspects of health. What are we looking for instant feedback? We are looking for consistent results. It doesn't matter of your age or race or ethnicity. Also explainability. The doctors, they want it. They don't want to take some decisions if they don't understand why. And of course, increase accuracy. As I said before, there are many ways to use data to do some good diagnosis. There are here I put some of them. For example, in medical image analysis, you can see CT, OCT, or other these ways of taking some information. But also there are many others, like signals, voice, analysis, for example, in test, genetics, medical administration, monitoring, robotic surgery, etc. So we have a lot of opportunities. And normally the problem is that most of the software that we have available, they are like black boxes. I think this is a common problem, not only in medicine, but in many other areas. There is no explainability, the bias and discrimination, difficulty in debugging errors, and many other issues. The problem is here is that, for example, we ask a system to, I mean, the input normally is an image, and then the black box, they do something with a neural network, and the output is, okay, this person had this illness. So normally the doctor, they don't like this because they don't understand why the system makes this choice. So this is one of the biggest problems in artificial intelligence. So I will start with talking about some projects that we have. For example, this one is for detecting glaucoma in patients that go for the first time to a clinic for evaluation. We are doing this with the Instituto Mexicano de Oftalmología, and these are our medical partners. We are focusing in glaucoma because glaucoma is important for them. It's a illness with difficult to diagnose. And we are using retinal images that can be used not only for glaucoma, but they can be used for detecting other ocular diseases like the diabetic retinopathy, hypertensive retinopathy, and other things like retinal tumors, etc. They can also be, okay, maybe not quite used, but they also can be used for mental and neurological disorders. Like multiple sclerosis, concussion, Parkinson's, and Alzheimer's disease. Some of these diseases can be seen in some images, not very directly, but they are related. In glaucoma, for example, your vision starts to decrease. The periphery vision. So this is how a person with glaucoma starts losing their field of view. What is concerned is the prevalence, for example, in Mexico is 2.5 of the adult population, like 2.7 million. So there are a lot of people that have glaucoma. And I said before, it is difficult to diagnose. Normally, ophthalmologists to detect glaucoma, they use many instruments. Like I said before, they look at the patient history, an examination, they take the intraocular pressure. And normally they take some photos like fundus image, like with a fundoscopy, or they take a tomography with OCT. And with these images, they and all the other information, they start to make a decision. There are other tests they do, like visual field testing and intelligent chamber assessment, etc. And of course, we cannot do all of the steps in using artificial intelligence. Okay, there is a way to do many of them, but we are focused on these imaging devices. Normally, glaucomatologists, they take a lot of symptoms. Here, many of them, they normally take some mechanical changes or vascular changes. We will not explain all of them, but they are things that they can see in the images. And this is retinal images. This is the left one is the fundus, and then the right one is the OCT, the tomography. And when we are talking about glaucoma, we are focusing in the nervio optical, in this part, in the left of the fundus image. And one of the things they measure is the cup and disc diameter and the relation. And this is important step to do it. We can do it using object detection algorithms and segmenting algorithms, and we have done this very good. If you want to hear read more about this, we have to this paper. And there are other things that they can, for example, the retina nerve fiber layer. You can detect also using an algorithm. We use this also with a neural network, and it is also in this paper we want to take close view.
Dr. Tovar, we are almost on time, please.
Okay, I will finish.
Thank you.
Yeah. Okay. There are many other things that we can find in the images, and some of them are here. And of course, we are developing a software to do this automatically. But the difference is that we are doing this like a doctor, not only like a black box. So we are showing them why we find or where we find the problem. We have other projects, for example, this one for finding neurodegeneration, like cognitive impairment. This is using audios, and the problem is that normal or actual software they use they just take the last steps of dementia, for example, when the illness is already very it is easy to see it even for a normal person. So we are focusing in mild cognitive impairment using only audio. We are kind of using this neuropsychological test, but we are capturing the audio, and then with using this information, using natural language processing and using some sound features, we can give the diagnosis. So the different we want to have a different approach for when you go to the doctor, for example, combining these two projects that I just present you using ophthalmography, fundus images with AI and audio, for example, we can find many other illnesses. And just to finish, I think we can easily use this information with audio that is cheap and this image, fundus image that is cheap, and to make some generalist. So this is my conclusion, some generalist and mass access systems. So this is important for the public, not just to focus on some illnesses. We need clinical validation, and we need integrating this into the medical practice, and we have human-machine collaboration. So physicians should deploy AI as tools rather than replacing humans. And this is the last. This is one initiative to go to medicine 2.0. And that will be all my presentation. Thank you very much.
Okay, thank you, gracias. First, I want to thank you, Dr. Professor Dimar here for her leadership in I-MMAS and her wonderful team at I-MMAS to make this happen. This is a lot of work, tremendous, a lot of leadership. Thank you to you all, and thank you for being here. So I'm so happy to be here to talk about AI Learning Collective. So but before, let's backtrack a little bit to talk a little bit about, my journey so far. And my name is Haiji Cheng. And actually, I got my bachelor degree from the U of I, Urbana-Champaign. And then I went to the East Coast and went to Yale to get my PhD. And then I came back to Central Illinois, Now, where I am right now here is Springfield, the capital of Illinois. It is also, I'm at the Springfield campus of the University of Illinois system at the Springfield campus here. I'm associate professor of mathematics and data analytics. But for the last 2 years, I was so fortunate that I could be able to work with Professor Neetu Singh, who was also a keynote speaker earlier this morning. And we co-found the UIS AI Campus Learning Community. Now, I know it's a long name, so I'm going to say it again. It's the AI Campus Learning Community. And let me tell you briefly about, this AI Campus Learning Community that we co-found. Now, our mission for the AI Campus Learning Community is that we want to bring learners and experts together to promote AI literacy for everyone, for all. Not just for people who can pay, but for everyone, for all. Now, for the last 2 years since our launch, we have been very fortunate and grateful for the opportunity to work with different partners. We were able to curate multiple events reaching an audience of over 1,000 people. Now, a lot of them are in person. Also, some of them are remote participation. So I'm very grateful for the opportunity to reach so many people. And our biggest event was the Day of AI, which happened 4 months ago. Now, can't believe that it was 4 months ago. It was only 4 months ago, April, 4 months ago, Day of AI. Now, what was that? It was a high school focused event, and we were able to bring in over 400 regional high school students to our campus. Now, some of them came from local, but some of them travel like 3 to 4 hours to be there. Now, that day of AI, that program we focus on AI and career pathways. AI and career pathways. We had wonderful speakers from Microsoft, from the Argonne Labs, and it was wonderful. And I have to mention, we have pizza too. We have lots of pizza. Everyone loves pizza, and it was wonderful. And you are seeing some pictures here of the some events, and up there you see a new Aruba. She was one of our student. Because in that Day of AI, we also have AI Talent Expos to have our students to showcase their AI project to engage high school students. A wonderful experience for everyone. Love it. And about learning collective, what we do in the AI campus learning community, I think we can kind of summarize it by 3 keywords. 3 keywords. What we do and why we do it. Now, the first one is about diffusion. Diffusion. We are talking about spreading AI literacy across communities. Spreading AI literacy across communities. The do's and don'ts of AI, because AI could be AI is a powerful tool. It could empower people. It could build communities if we know how to use it. And so it is that's the utmost important for us. And AI is also, is disruption. The second word, disruption. AI is a disruptive technology because AI is shaking up, jobs. It is fundamentally changing the way we educate. It also fundamentally changing the way we and our students learn. And not to mention, it is changing our life, as we see it unfolding. And so, we want to make sure that we're able to educate others so that they know, people could know the skill set they need to adapt to these changes and to respond to these ever evolving changes. And that's why, the Day of AI we were focusing on AI and career pathways. Now, talking about, being a disruptive technology, in terms of, career, what we can see right now is that, yes, AI is very disruptive. It's displacing some of the work, some of the opportunities that we are familiar with. So down the road, some of them disappear. And we worry about this, of course. But at the same time, we at this point cannot see, or we cannot even imagine the new opportunities that AI is going to bring us. Now, just take an example. Think about YouTube. 20 more years ago, when it first launched, nobody would have imagined that YouTube would become what it is today. Now, as of today, YouTube is worth over $500 billion. 500 billion with a B, $500 billion. It has over 5 billion, also a B, 5 billion videos, content. And at any given point, there are around 4 to 5 million people. Now, this time it's the M, 4 to 5 million people watching it. Now, maybe you are one of them right now. I know I'm not a particularly, eloquent speaker. So, if you're watching YouTube, I understand. But hope that you can, stick with me. And, that's the hallmark of disruption, disruptive technology. But think about, just for YouTube, the kind of opportunity that it is creating, along the way. What we want to do is to help our learner to realize that, hey, there are new opportunities popping up. Hope that you will be positioned to turn some of this opportunity into positive impact for you and for your community. That's disruption. Disruption brings also opportunities. And also about design. We're talking about, designing and creating new ways to learn with AI, to help our learners, to help ourselves to use new technology, AI to learn. It is about scaling human intelligence. Now, I want to share with you a very fun, interesting experience that I had over summer. Now, there's that's the second picture here. This is a picture that I was teaching a summer camp, high school summer camp this summer, and it was targeting high school students. And during a camp, we have an activity called a conversation with Satya Nadella. Now, Satya Nadella is the CEO of Microsoft. Now, we did not work this out earlier enough so we could have a real conversation with the real Nadella at our camp. But, instead we used Microsoft Copilot to generate AI agents to have that conversation. Actually, we generate 2 AI agents for that. One, of course, is the agent Nadella based on his talk. You can find online, and we want to prep our student to talk with him about social permission and technology in specific AI, because Nadella has been talking about social permission and AI. And so we actually create, the cool part is that we create a second agent. This second agent is a communication strategist, because the constraint is we said we only have 15 minutes with him, just like what I have, 15 minutes. So you need a strategy. So we make a second AI agent to have through conversation to prep the student on this topic, social permission and AI. And then through conversation, this AI agent help the student to come up with 3 questions. But not only that, the same AI agent also through conversation to help students to come up with a communication strategy to carry out that conversation. So it was pretty fun. It was pretty fun talking about you learning, designing new way to learn with AI. Now, moving forward. And well, I want to tell you a bit, some of the things that we are going to do this year, and hopefully we can also include you. Firstly, with Getz Hill Center at Chicago. Now, you may not familiar the geography here. Getz Hill Center at Chicago. It's just like if I drive, I have to drive 3.5 hours there. No speeding, 3.5 hours. So it's far away this. And Glad Hill Center is a nonprofit organization founded more than 100 years ago. And they are providing children and family support services, and they primarily serving Latinos and African Americans in Chicago area. And in May, 3 months ago, we went there to talk to these kids about, AI. Now, this picture here, you see, that's the picture from that event. You can also find this picture from my LinkedIn page. Now, you can see that these kids are around 13 to 18 years old, is part of their, after school program. And so we had a great time. And so that's why this September and this October, we are going back again. Now, if you're in the Chicago area, you want to be a part of it, let me know. We'd love to have you there too, to talk about AI to these kids. And also, early next year, 2026, January, we are going to have a educational technology conference here in Springfield. It will be a one-day in-person event. We are going to bring in, regional K-12, meaning, high school or secondary school or primary school, principals, administrators, decision makers, their IT directors, bring them here, as well as with representatives from Google, Amazon, and Microsoft, so they can come together to talk about, to explore new and innovative way to teach with AI. And we're so fortunate that this time we can be working with the Illinois Business Education Association. They have a network of over 2,000, business teachers in Illinois. So we are very excited about this coming event. And if you want more information, let me know. Last but not least, what about an international collaborations? Maybe, just maybe, a Latin America US Day of AI. How about that? This is a call for actions and collaborations. Now, if anyone is interested, we can do it here and with you, in Latin America. It will be, now let me describe to you what it could be. It could be a one-day hybrid event, pretty much like, what we are having here. There's an international conference. If we are starting to plan, maybe a year from now, and the purpose is to bring the young people, the leaders of tomorrow, to come together from different places to think about, to have that vision, to cultivate that vision, to imagine, to explore ways that, AI can positively shape their world, their future, to learn and engage, to connect with each other through technology and to inspire each other, and to let's build a community that we all feel belong. Now, if you're interested in any of these events, you can easily find me. Take a picture here. You can search on your LinkedIn page, Hi Chi Chen. And when you see that picture, that's me. Well, thank you. That's all I have.
We all know that agriculture faces the challenge of feeding a growing population while dealing with pests, diseases, and a very limited access to technology in the field. Deep learning is a powerful AI automation tool for doing recognition of pests and diseases, but it is very difficult to apply in real-world farming. Many barriers have to be faced. Deep learning requires large data sets, high computational resources are needed, and we are dealing with field conditions that are unpredictable. We have variable lighting, wind, very small objects to be detected, such as insects. As you can see in this image, there is a very small red spider on this crop, and even for the human eye, it's difficult to recognize. So this talk presents two contributions. The first one is a bio-inspired pruning algorithm that addresses the problem of that deep networks are redundant, over-parameterized, and redundant algorithms. So training and inference require GPUs or servers that are not available in rural contexts. We took some inspiration from neuroplasticity of the human brain, that after injuries, the brain has the capability of remaps lost knowledge onto healthy regions. So we were asking, what if we simulate an injury on an architecture of neural network? We get this proposal. We can prune, we can cut entire blocks of the architecture, of the original architecture, and we can get compact neural models that enables running deep learning models on low-cost devices. We have this neuroplasticity algorithm, and we reach up to 80% compression on MobileNet and MobileNet version 2, depending on the dataset we use to train. But we can now implement these deep learning models, these deep learning neural models on very low cost devices. Using this compression methodology, we train compact neural networks to recognize, as an example, fruits at different ripening stages. You can see that we can classify 5 classes of fruits at different ripening stages, and this enables farmers to better organize harvesting and packaging, thus optimizing time and resources. This also facilitates direct technology transfer to local farmers, even when resources are limited. The second contribution is a pest recognition motion-aware deep learning model. We are facing the problem that pests are small, camouflaged, and often they are moving in natural fields. So we propose a solution based on the architecture YOLO V8. We added a motion model to this architecture. This motion model takes 2 consecutive frames and computes a future map difference to extract motion cues. Let me show how simple is our motion model. In this image, you can see at the right the architecture of the motion model. We can insert this motion model after the first blocks of the backbone of YOLO V8 architecture. After V3, V4, or V5, we have reached very good results. And also, we have many advantages. We don't need preprocessing, as we need when we use optical flow or frame differencing. We are very robust to lighting changes, and we have an increase of 5% of map 50 metric and 7.8 on recall metric, respect to YOLO V8 Nano. This implementation of our motion model led us to design a very simple monitoring system, monitoring pest system and let me show how almost artisanal system we have. You can see here in the field, this monitoring system that consists of a couple video surveillance low-cost cameras that are connected to an Arduino platform. Here, there is the platform inside this box, and we can, this system send images and video to our server, where is the neural network that recognize pests and diseases, well, pests for now, and we have so many good results. You can see here that in real time we are capable to recognize some mites, myates, weevils, thrips, red spiders. You can see that even for the human eye on this image, is very difficult to see that there are a couple insects on the plant. And also, we are monitoring these large stickers. These stickers contain some insects. We are monitoring in real time this crop, and we are reporting the farmer the count of each insect daily with a very simple system that use deep learning. There are 3 images as an example of pest recognition results with variable lighting conditions. You can see that we have some image with high contrast here, but our system can recognize there is a little bee here, or here, here, here. You can see it is a difficult task, but deep learning is precise and recognize these little insects in real time using this motion-aware model. Well, as conclusion, I think that we have to think on designing systems which are efficient and robust to enable practical AI in agriculture. I think also that the goal is not only to reach higher accuracy, but also transferable technology that local farmers can actually adopt to improve productivity and sustainability. These are some bibliographic references from our works. These 2 are for the neuroplasticity-based pruned method, and we also have a GitHub open access repository where is the neuroplasticity algorithm that you can test. This publication is about the motion-aware deep learning model that I have presented to you. And finally, let me introduce the work team in the field. We are working now with local farmers to transfer this technology, and they are using it and testing it in the field daily. Some acknowledgement, and thank you for your attention. This is my email if you are interested in collaborating or on any of these projects.
Good afternoon, everyone. It's a pleasure to be here to talk with you about digital agriculture and how it has advanced in the past couple of decades. First of all, I want to start out thinking in context, as despite the advancements we have made, we have many global bioeconomy challenges. We need to increase our food supply and grow more food, especially by 2050. We have limited or declining resources to help do that. Water, land, fossil fuels, and nutrients are all important. And our bioeconomies are experiencing climate change and climate variability and there is increasing concerns about greenhouse gas emissions. Agriculture uses half of the arable land and over half the available fresh water. And unfortunately, for all the effort our farmers go through, between 30 and 40% of produced food is waste, much of it discarded into landfills. And we have this general degradation of water, soil, atmosphere, and ecosystems from long-term production practices. And our natural resource use, the cost of them exceed over 1.1 trillion per year on food. However, the true costs are likely more like 2.3 trillion. So despite all of the good things we've done in growing the economy, I think we have opportunities to take advantage of the way that the digital technologies have impacted the rest of society. And it's been true for precision agriculture as a tool for integrating digital technologies into large-scale production agriculture. And this will enable us to address some of these challenges in the long run, driven by the data and the automation and control opportunities that we can execute with these machines. Let's start with how have digital technologies occurred in agriculture, and it's been largely in large-scale production agriculture. We had an amazing increase in mechanization for the last 100 years through mechanization that helped fewer farmers produce more through the use of tractors and wider equipment and the brawn of machinery, so to speak. But in the 90s, there was the beginning phases of precision agriculture, and it had its ups and downs, but it really took off with automatic guidance. And guidance was something that could address labor availability, reduce skill level, and have high precision that allowed farmers to increase yields on acres that were planted more precisely. And this has went through generations of change the past 20 years, leading to smart connected equipment and increasing uses of AI that I'll talk about. But for today, we actually are also in this transition towards autonomy and as part of the solution set. And I like to phrase that automation to autonomy, because we should expect that we will have a mixture of human-driven and automated machines, autonomous machines into the future for quite a while. Okay, so the digital technologies that are in production agriculture enable farmers to quantify the job outcomes through the smart connected machinery. And by having these productive machines, this leads to precision job outcomes for the tasks that they're performing. And that's enabling worksite optimization. So taking the collection of tasks that are involved in agriculture and allowing that worksite to be optimized and gain further productivity increases at a large scale level. And I will talk a little bit, hopefully later, about these tools. By having this data, we have data, we can measure things, then we can make it better. And my premise is that digital agriculture will enable and put us on a pathway towards sustainable productivity, where we learn from the data and we can react to it and make decisions that are informed and to overall benefit of society. So when we talk about agriculture, how much of it is digital in the large-scale production agriculture? And nearly every job step today, every job step really is integrated with the abilities to sense, measure, manage, and control, and use that data and store that data and aggregate it and then use it post-season. And if you're not familiar with the job steps in agriculture, there's the preparation of the field through tillage, there's planting the seed and being able to do that very precisely. There's protecting the crop by applying chemicals or nutrients during the growing season. And there's harvest of that crop and then moving it into the food chain for processing. And you can see these are all showing kind of large scale systems. And these technologies are not uniform across all of agriculture. As the last speaker alluded to, there are increased opportunities and significant opportunities to help small to medium enterprises benefit from these technologies. They probably don't start with guidance like this particular review shows, but start with things that are available to the farmer in the market through mobile technologies and being connected to computing on their farms. So this is what the modern ag operating system looks like. It combines a number of important features, starting with high fidelity location that's driven by high multi-constellation, multi-frequency GNSS or global navigation satellite systems. This enables the accurate positioning and control of machine systems to 2.5 centimeters and allows repeatability across the production cycle. After that, there's increased desire to communicate between machines, and that led to connectivity, which allows the and telematics that allows precision management of the equipment, machine-to-machine communication to have machine systems work together, and performance reporting and optimization based on those machine systems. And then following that, for about the last 15 years, cloud-based data services that have helped create farm management information systems that allow advanced farm planning and operations and data sharing across the farmer's value chain. More recently, we see increased electrification, and it's been around for also about 15 years. We're seeing some people talk about the value of it for powertrain optimization and in getting increased efficiencies like we see in some of the automotive sector. But I think the real value of this is in the precision control of implement and task that allows the machine system to create more precise outcomes based on the precision location and positioning information that they have. So our machines have become more digital than ever. We have sensors on our implements and machine systems and tractors. We have communication technologies in the cab. We have real-time data being connected and used, machines that can operate off of maps as well as operate off of sensing. We have positioning through GNSS. And then at the office level, we have this ability to integrate these things together through operation centers that can help manage small to large farm systems. So our machines have become more digital than ever, and this is an enabler for optimization to help us achieve the best outcome for each production step. And we can see that in a number of ways. On the left side, you see the planting systems that have high precision, high speed, so that plants can be placed exactly where we want them. This is enabled by a combination of the GNSS technologies, the control technologies, as well as innovations in planting that allow these seeds to be almost sowed in the ground at a very precise location. We have the ability for machines to work together and relieve stress on the harvesting machine operator by coordinating the movements of these machines together and allowing them to be more timely in their operations. And then you can see on the right side, the early outcomes of guidance is that the fields look beautifully straight, which actually a farmer pointed out to me that having more precise rows and the straightness of it gave a higher packing density of plants, and so that results in increased yield. And so many of these things have been driving productivity, but it's also driven convenience because we have fewer and fewer operators and farmers on these systems, and they have to deal with issues of skill level and experience and a long working day, and the technology's always been able to help with all of those things. So let's talk a little bit about AI, and AI is not new to precision ag. It's been around for, has evolved in other sectors. And if it can show value for the farmer and create impact, then the adoption has been very good. And I'll give some detailed examples of each of these, but I'd like to categorize them into 4 areas. It's helped improve machine performance for things like vision-based guidance that uses computer vision and machine learning to see the paths and to guide the machines down rows very precisely. Path planning, mission execution, benefit by being able to take fields and understand the most efficient way to perform operations on those fields. AI has also helped augment human performance, and you see the automatic unloading system. Stereo vision can help sense the fill of a machine and synchronize the machines together so that the combine operator can focus on harvesting and the tractor operator is moving in sequence with the combine based on the sensing of his machine or his wagon being filled optimally. We'll talk a little bit about multiplying human performance. You can see driverless tractors are just starting to be talked about. And in that space, autonomy opens the door of having one person to be able to multiply their workforce by being able to control multiple machines in the field at one time, and even exceeding human performance, as evidenced by see and spray technologies, for example, which use computer vision and machine learning to see the weeds at high speed on a very wide machine, 110-foot boom, as it drives through the field at 15 miles an hour. And it's able to precisely locate weeds and only turn on the nozzles for areas that have concentrations of weeds. So I'll quickly show an example of each one of these. And here's the improving machine performance through guidance. And you can see the, hopefully you can see this well, but the tractor senses through vision the location of rows and steers the vehicle through this monocular camera located on the cab. That's essentially an RGB camera that looks out across the crop and helps guide the vehicle to stay down the lanes appropriately. The synchronized machines of having a forage wagon, we showed this previously with a combine, but here's a forage harvester that's cutting very tall forage, and the tractor driver and a combine driver can't even see each other, but they can communicate because the stereo vision system is sensing the fill of the wagon and helping to nudge the tractor backwards and forwards during the fill operation until it's fully loaded. And that improves the timeliness of operations by allowing them to work at the most effective speed while they are performing these operations. And then exceeding human performance, you can see on the right side of the ability to be able to label weeds differently from plants and to understand if there's higher planting density. We can target chemicals towards the weeds using cameras mounted on the spray boom on this machine system, and controllers that basically GPUs that use computer vision machine learning to identify plants and weeds and then decide if a nozzle needs to be actuated. And finally, the driverless is just now starting to emerge. It's causing machine systems to have more integration of more sensors into the cab, stereo vision and monocular vision and other forms of sensing, to have this awareness of what the operator sees when they're driving. And vision isn't the only thing an operator needs. Sometimes they feel vibration from the implement performing poorly. And so there's actually still a lot of work to do, but we're seeing early use cases that are beneficial in performing certain tasks. And this has to evolve across the entire production system over time. And then data, we keep having, as these machines can collect data on the seeds where they're planted, the operations that take place, the machine system's health, that data that's taken on every pass becomes a learning opportunity that can help optimize the equipment through more precision. And so the data will be an enabler for optimizing the work site. Having that data is quite difficult to analyze so much of it, and AI will be helpful as a tool to help create insights from the massive amounts of data that are being collected. Okay, I just like kind of reflect on the journey we've been on. We have been working over the past couple of decades towards improving machine productivity, and starting with guidance. There's been the improvements like in understanding the health and state of the machine and increasing the ability to adjust machine systems more precisely, adding mission planning to cover entire fields or coordinating machines together. And, we reached a point where now we're looking at AI-enabled decision-making, and this all will lead to optimize human-machine solutions. And so at the task level, we can see that these machine systems are performing, but at the same time, we've been on a journey towards optimized worksite solutions through autonomy. And these worksites have been leveraging the data to provide connectivity between machines, to link the machines to cloud, to have other sources of data like IoT or remote sensing or drones that provide additional data that can be leveraged in the farm management information systems. And we're at a point today where we have job step automation to autonomy, where the job step might be planting or tillage individually. As we bring these systems together, the fleets of machines that are working in the field will be optimized and can be autonomous solutions. But as I mentioned, I believe automation and autonomy will go hand in hand for quite some time. And one thing I'd like to point out is that there there isn't just a defined pathway that we will only end up with autonomous machines. I think we should expect that for a long time, we will have manned and autonomous machines in the field at the same time, building on this precision agriculture platform that's been built. And we may even see that AI will cause us or want us to do things like the See and Spray of having intelligent implements that use AI to help the farmer and work with the farmer to perform the task more accurately versus trying to take the farmer out of the seat. So all of those pathways are kind of a combined future with a lot of opportunities for improving productivity. I think autonomy will also open the door to new machine forms. And will it just be to traditional equipment that's made autonomous? Will it be smaller machine systems that have some benefits, but also have some limitations and power to perform the task? Or in the middle, there may be even specialized machine forms. And this is another place where the future has lots of opportunities. And we are likely to see novel solutions that we've never realized before. In fact, this week is the Farm Progress Show in Illinois, and there's a company there that is showing a solar-powered spraying system that moves fairly slow, but it moves continuously through the field and helps protect the crop that way. So again, I think this is a really exciting time for the people that are interested in AI going into the future. And then Gen AI, I can't leave this talk without mentioning Gen AI. It's very much emerging. We've developed a system called Crop Wizard. That's an advisor for pests and diseases. It's actually part of UIUC.chat. It was built on that platform. And we built it as a tool to help extension agents. And the data that's loaded in this system is USDA data from extension. And so it's a kind of a chat bot that's really interesting. You can go to the QR code here and try it and ask questions and see how it works for problems that you have. It has actually quite broad applicability. It has the retrieval augmented generation database from this data, but it also still links with other LLMs. And so the challenge with these question and answer systems will be the ability to trust them. And I'll talk about that in a second. But what's really nice about these systems is that they are going to lead to more than question answer systems and future agentic systems that might be in the cab or in the home office that further give the farmer tools to increase their productivity and convenience. Actually, it looks like I left the benchmarking slide out, but AgriBench is a benchmarking consortium that we've just launched yesterday at the Farm Progress Show, and its purpose is to focus on how do we evaluate the accuracy and effectiveness of these question answer systems, because many companies are developing them, and we want to bring them together into something that the farmers can trust so that we can continue to accelerate this journey towards an automation to autonomy. So in summary, digital technologies are the driver for innovation in agriculture and have been for a couple of decades. The modern ag operating system allows us now to quantify the job outcomes enabled by the smart connected machinery. Production ag is transitioning from focusing on just the productive machines to precision job outcomes and opportunities for worksite optimization. And the AI solutions that are part of today's solutions are critical. And AI has a really interesting journey ahead with Gen AI and other advancements that will come to play as being part of these systems. And thank you.
Okay, thank you. I have prepared some words, so I will try to keep on time. So good afternoon, everyone. As we come to the end of this symposium, Artificial Intelligence, Opportunities, Challenge, and Multidisciplinarity Collaboration, I would like to thank you all for your time, your ideas, and your energy. We have spent several hours together, and I know it has been a long day, but also a very rich one. Over these sessions, we have seen the many phases of artificial intelligence. We learned about new methods in machine learning, applications in healthcare and agriculture, language technologies, and even the role of AI in urban safety. We also heard about the importance of ethics, responsibility, and human values in the design and use of AI. But what connects all these talks is a simple truth. AI is not only about technology. It's about people, about collaboration, and about building trust across disciplines and across countries. This event brought together hundreds of participants from Mexico, the United States, and other nations. This shows us something powerful. The challenge we face are global, but so are the opportunities. And only by working together, we will find the best solutions. I want to highlight one more idea. The future of AI is multidisciplinary. Engineers, doctors, social scientists, educators, and many others all have a role to play. No single perspective is enough. Collaboration is our path to innovation and to responsible progress. So, as we leave this symposium, I invite you to continue the conversation. Let today be the start of new partnerships, new research, and new projects. Let us carry with us the inspiration that AI can improve lives if we use it with wisdom, fairness, and care for our communities. Finally, on behalf of the organizers, I sincerely thank your speakers, our moderators, the technical team, and of course, all of you, the participants, for making this event possible. Thank you once again for being part of this exchange of knowledge and experience. The future of AI begins with collaboration, and it begins with all of us. Thank you.
And thank all of you. On behalf of the I-MMAS, the University of Illinois system, I want to thank all the speakers for your time. Thank you for your meaningful and engaging presentations. Thank you for the exchange of knowledge and experiences on the highly relevant topic of artificial intelligence. You focus and address multidisciplinary dimensions and real-world applications. So congratulations to all the speakers. Thank you, Dr. Ferruska, for your closing remarks, and thank you to all of you for all what you do on behalf of science, technology, and innovation.